Hello everyone. Welcome to the sessions on the advanced communication. Myself Usha Mirajkar, selection grade lecturer, Government Polytechnic, Belgaum. In this particular session, we are going to learn in the unit 6, that is mobile and wireless communication. In this unit, this is the session 11. In this session 11, we are going to learn about the Zigbee technology. The contents which we are going to cover: introduction to Zigbee, Zigbee addressing, network topologies of Zigbee. Now, what is the Zigbee here? Zigbee is an IEEE 802.15.4 based low power, low data rate supporting and the wireless networking standard here. That is, it is having the property of the low power here, low data rate supporting, and also the wireless technology as well, low cost here. This is the Zigbee technology. Now, which is basically used for two-way communication between sensors and control systems. It is a short-range communication standard like Bluetooth and Wi-Fi, covering the range of 10 to 100 meters. Now, if Wi-Fi and Bluetooth are already there, then what is the need of Zigbee here? Because the Wi-Fi and the Bluetooth, they won't support the control and the sensors as much as the Zigbee supports. Therefore, Zigbee is mainly designed for the control and the sensor equipments here. That is the main purpose here. Now, the Zigbee addressing modes here, there are mainly three types of the addressing: broadcasting, group addressing, and the unicasting addressing. These are the three methods of the addressing in the Zigbee technology. Now, the Zigbee addressing, that is, this one is the broadcasting addressing. Broadcasting means what? Sending to all. That is, the whatever the messages are there, those are broadcasted to all the nodes. Means all the nodes will receive the message. If you observe here, the coordinator or the central hub, it is transmitting the message, and this is received by all the nodes here. Correct? Therefore, this is called as the broadcasting type of the addressing here. A broadcast message is a message that is meant for all modules on any given personal area network. Therefore, all nodes or all modules will receive the message here. In Zigbee, a broadcast message is sent once and then repeated by the neighboring coordinator or the routers. That is, once the message is sent and afterwards it is continuously repeated by the corresponding routers here. Now, once the broadcast message has been repeated a certain number of times, it won't be repeated anymore. It is having some limitations there. Up to those counts it is repeated, and after that count it is stopped. Again, if that particular message it is not sent to the particular destination, again it has to be resent there. That is the procedure. That is, a broadcast message can only propagate so many hops before it will stop being rebroadcast. Therefore, again it should be rebroadcasted. Anytime a router receives a broadcast packet, it does two things. That is, whenever any router receives the broadcast message, primarily it is doing two things here. That is, determine if it must retransmit that packet. If that packet has to be retransmitted, to check that one, it will check the first one is the first checks the source address of the who sent the broadcast packet. That is, the whatever the packet it is arriving, it is having the source address. Therefore, the router will check the source address. Then it checks the sequence number of the packet. So, sequence number, which packet, the number 1, 2, like that, which packet it is. If both of these pieces of information are matching here, then the particular, these all informations are present in the broadcast message header, and it will check those things, whether it needs to be rebroadcasted or not here. If these values doesn't match, then what it will do with an internal broadcast transaction, then the router keeps it will retransmit the packet. Again, it is retransmitted if it is not matching here. That is the procedure. Now, next one is the unicast addressing. Unicast addressing means what? It is from point to point, one person to other, or one node to other. Therefore, in the unicast here, The path will be selected once the transmitting and the receiving particular stations are detected there. Then that mesh type of the network is established, and through that route only it is transmitted here. Therefore, here all are not receiving here. Only who is transmitting it, to whom it is transmitting, only they are receiving. In between, you will be having those rotors and the other nodes there. That is the unicast here. Unicast message is a more reliable method for the delivering the data, because it is not broadcasting to everyone here. Unicast message is sent from one module to any other module based on the module addressing. That is, the header is having the address of the source and the destination, where to transmit and where it is coming from here. Once the appropriate module has been found, then the message propagates through the mesh network. Therefore, when the path is selected properly, where is the source and where is the destination, then the mesh is created there, and through that only the signals are transmitted here. Now the group addressing. In case of the group addressing, a group is created here. That is the collection of the endpoints or the nodes here that is created, and through that group the message is transmitted here. For example, if you consider the group addressing, a communicate with a group of endpoints belonging to the set of devices here. A group aren't just there to group, but it is to also to fix the path here. That is the main purpose here. To reduce the Zigbee traffic, also this grouping is done. For example, if you consider, we are having the 3 lights, bulbs in the particular home automation here. If those 3 bulbs are grouped here, then we using one command only, we can turn on and turn off all the 3 bulbs here. But if those are not grouped, for each bulb we need to send the different commands here to turn on and turn off. Therefore, grouping will reduce the traffic here. And we using the single command, we can control there. Therefore, this is the group addressing. Now the network topologies. Which are the different types of the network topologies? If you observe here, this is the tree type of the network here. This is the star network, and this is the mesh network here. The blue dots indicates the Zigbee router. The brown color dot indicates the Zigbee coordinator, and the green color router indicates the dot indicates the Zigbee device here. Okay. Now, if you observe the star type of the topology, the coordinator is managing all the devices here. Means it will be managing the connection, and it will be initiating the connection and transmitting the message here. Through this particular coordinator only, all the devices are connected here and they are receiving the message here. In case of the tree network, if you observe here, the routers are connected to the Zigbee coordinator. Again, through this router, again we can extend the network by connecting the some more devices here. But all they have to do is they can communicate through this coordinator only here. Through this coordinator only. If you observe the mesh network here, again through the coordinator, we are having the different routers, but it is not compulsory that these routers are directly connected to the coordinator as in case of the tree network. But those are connected from one router to other connection is also available, and through that again the different devices here. Therefore, this is the mesh type of the network here. Each network topology consists of 3 types of nodes. One is the Zigbee coordinator, Zigbee router, and the Zigbee end device. What is the function of the coordinator here? The coordinator performs the task of allocating unique address to each device. Means it is allocating the unique address to the each device here in the network. Initiates and transfers the messages in the network. It is initiating and transferring the messages, and also selects a unique identifier for the network. For each network, it is selecting one identifier. Zigbee devices are of 2 types here. First one is the full function device, that is called the FFD, and the reduced function device, that is called as the RFD. That is the full function device is the FFD and the reduced function device is the RFD. These are the 2 types of the devices here. Next, in star topology, the coordinator is the central device which initiates and manages the devices within the network. The coordinator is the central hub here. It is initiating and managing the network here. Next is the each coordinator selects a unique identifier. That is, it is selecting the unique identifier which is not used by other network within its region to influence. That is, it is selecting one unique identifier for this particular network here. Next, each end device communicates with the coordinator. Means whenever they want to communicate the end devices through this coordinator only, they have to communicate. The end devices are generally RFDs, which can only communicate with the coordinator or the FFD here. Now, let us watch one small video, analyze this ZigBee technology.
Hello guys, welcome to another episode of Learn Technology in 5 Minutes by Makeademy. This is Arvind and I am part of the instructor team at Makeademy. In this video, you will learn about a wireless technology called ZigBee. Before getting into the video, I am sure that you are familiar with short-range wireless networking technologies like Wi-Fi and Bluetooth, which are used to connect devices. These technologies are fairly mainstream today and are used in specific use cases. For example, if you want to stream audio, you're likely to use Bluetooth. Likewise, if you are streaming video or larger files, you are likely to use Wi-Fi. But let us think of a use case where we can connect a large number of battery-operated devices. Is it okay to use Bluetooth and Wi-Fi? The answer is clearly no, because Wi-Fi consumes a lot of power and is therefore not ideal for battery-operated devices. Most of Wi-Fi devices, like your mobile phones or laptops, are usually charged on a daily basis. Then what about Bluetooth? You may say, well, Bluetooth consumes less power than Wi-Fi. So, would that not be ideal for our case? But you can connect only a limited number of devices to a Bluetooth network, and therefore, Bluetooth is not ideal for our case as well. So what could be better solution to connect a large number of battery-operated devices? Enter ZigBee. But what exactly is this term ZigBee? ZigBee, like Wi-Fi and Bluetooth, is a short-range wireless protocol. The ZigBee is built on top of IEEE 802.15.4 physical layer and is designed to meet the needs of low-cost battery-operated applications where longer battery life is the major concern. Unlike the other two technologies, ZigBee operates at a very low data rate of 250 kbps. And this low data rate is the trade-off we need to live with, because we are planning to optimize for low power network protocols that can connect many devices. A single ZigBee-enabled device can reach up to a range of 10 to 20 meters indoors in search of another ZigBee device present in the network. The ZigBee operates in a mesh topology, which helps a ZigBee device to transfer its messages to its destination via a number of intermediate ZigBee devices connected within the network. So what is mesh topology? Don't Wi-Fi and Bluetooth follow this? Well, in basic sense, topology can be termed as a way in which devices are connected to each other. In a mesh topology, there is a coordinator that sends the information, an intermediate device which carries forward this information, and an end device that receives the information. All the devices in this topology, except the end devices, can communicate with each other and are also able to change the paths to deliver the information if any disturbance occurs in the network. Whereas in star topology, there is no intermediate device and the communication is done directly between the coordinator and the end device. This disables the chance of establishing an alternate path to transfer information at the time of failures. Wi-Fi and Bluetooth are configured as star networks, whereas, as already discussed, ZigBee follows mesh topology. There are two advantages to using a mesh network. First, a mesh network increases the system reliability. Second, because of the way transmission happens in a mesh network, the short range of individual ZigBee devices stops being a problem. We can add a large number of ZigBee devices which need to transmit data just to the neighboring node. This way, very large networks can be built based on ZigBee. In fact, the Swedish city of Gothenburg is a giant ZigBee network where over 250,000 homes are connected together for the purpose of remote energy metering. Coming to the security associated with ZigBee. It uses a 128-bit AES algorithm to encrypt and authenticate the message signals via the links, which are secured by special keys, allowing the end user to use the device in a secure manner. So, where do you think ZigBee is being used? Well, it is extensively used in smart homes to remotely access electronics and also in smart metering. That is all from me in this video, folks. If you like this video, then subscribe our channel and ring the bell so that you don't miss any videos.
Okay. I hope you have got the basic idea about the ZigBee. Thank you for watching. In the next lesson or in the next session, we learn about the what is the ZigBee stack and the applications there. Thank you.